Dear learner, welcome you all to today's counseling session. The topic of today's counseling session is in fact stack and queue and its application. When we talk about stack and queue, so we know that it is a kind of linear data structure. Data structure are of two kinds mainly. One is the linear data structure and another is the non-linear data structure. In the linear data structure, we study in fact array, linked list, stack and queues. Under the nonlinear data structure, we study trees and graphs. So today we will discuss in fact the linear data structure stack and queue. We will, after going through this lecture, in fact you will be able to understand the concept of stack, how the stacks are implemented. So we will discuss two ways of implementation using array based implementation of stack and linked list based of implementation of stack. Thereafter we will discuss the applications of stack. In fact, though there are a lot of applications, we will see where stacks can be used, how it can be used. Then you will be able to understand the concept of queue and what are various types of queue. We will discuss about it, and then we will discuss how the queues are implemented using the data structure arrays and queue and linked list, and at last we will also discuss few applications of the queue. So let us go one by one. So as I told, the stack is basically also known as LIFO. LIFO means last in first out. So when we see real life examples, for example, if we have a CD container, so in the CD container, how we put the CDs inside that, because it is open only at one end, so insertion of the CD and retrieval of the CDs takes place from only one end, and that is the top of the stack, top of the container. There are many other such kind of applications, such kind of things, like when we see in our kitchen, so we will find that there are many containers in which the items, food items or any other items are inserted using is stack concept. That is, the item which is inserted first will be retrieved last. So these are the few examples of stack. So stack in fact is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same end. So, and that end is known as top. So insertion and deletion both takes place from the top of the stack. So when we see the stack, which is, as I told, also known as LIFO, last in first out, so there are some basic operations which one can perform on it, and these basic operations are basically push and pop, which is also known as push means insertion or to put an element into the data structure stack, and pop means to remove an element from the stack. So these are the two basic operations. So when we try to perform these two basic operations, so we need to check certain conditions. For example, if we want to perform the push operation, we want to insert an element into the stack, then first of all what we will check whether the stack is empty or not, whether there is a space in the stack to insert the element or not. So if there is no space, then we will say that it is overflow condition which is going to occur. Similarly, when we are going to perform pop operation, then again we have to check whether there is any item into the stack or not. If stack is already empty, then we cannot perform the pop operation. So that condition is known as underflow condition. So let me discuss the algorithm behind these two basic operations, that is push and pop. So as I told you that push means adding an item to the stack, and if the stack is full, then it is said to be an overflow condition. So the basic algorithm for push operation is given in this slide. You can see that. So when we start the push operation, first of all we have to check the overflow condition, and that is been checked by this, the second statement, if stack is full. So if stack is full, then you can print some kind of message like stack there is overflow condition, and you can return back. And if this is not true, the if condition is not true, that is stack is not full, then we can go to the else part, and there we can increment the top. In fact, what is the top? Top is a variable, a point, we can say a pointer variable, or a variable which contains the address of the top element, or the last element which is being inserted into the stack. So, or we can say, if we are using say array implementation, it will contain the index of the element which was inserted last. So for example, in a stack, if there are say already 3 elements existing into the stack, then the top will be pointing to the third element. So obviously if we want to push any new item, then it should be inserted onto the 4th position. So that's why we first increment the top, that is index value of the top, and then we store the element at that particular location which is pointed by the top, and that is stack top will be assigned the value, and stack top is it may be an array or so. And once we have performed, then we will, the end condition will be closed, and thereafter the entire algorithm. So that is a very simple algorithm for push operation. Whether we are going to use array implementation or whether we are going to use linked list based implementation, in both cases we have to apply this algorithm for performing the push operation. Similarly, another basic operation which can be performed on stack is pop operation. So pop means to retrieve an element from the stack or to remove an item from the stack. So as I told in the beginning that in case of stack, items are inserted and deleted from the same end, and that end is known as top. So the items are popped in the reverse order, that is the first item or the last item which has been inserted into the stack will be popped first. So for performing this pop operation, the basic condition we should check is that of underflow condition. That is whether there are elements into the stack or not. If stack is already empty, then there is no need to perform the pop operation. We can just display a message that stack is underflow condition. So the basic algorithm similar to that of push is been given here. We can see that the first step begin, and then we will check whether the stack is empty or not. That is the underflow condition. So if stack is empty, that is there is no element, then the program will come out. It may display some kind of underflow message and will come out, that is it will return, and if condition will be ended. Otherwise, if this is false, that is there are some items into the stack, then we can pop the top element one by one. So that is the shown by the else part. So store value of stack top. So obviously we will retrieve the element which is pointed by the top, and we will store it into some variable, and thereafter top will be decremented because the top element is been retrieved or popped. Then the top will point to the next element which is available into the stack. So top will be decremented in that case. So then it will return the value whichever is popped. So that is the basic operation of pop operation which is performed into the stack. So we have discussed the push operation, the pop operation. So let me see how the stacks are implemented in C programming language, for example. So as I told you that there are two methods to implement the stacks. One is the array based method and another is linked list based implementation. So obviously in array based implementation we first declare an array for the stack, because the limitation of the array is that we should tell what should be the size of the array. So we will declare that array, and also another variable we will take, say top. So initially the value of top is initialized, say -1. So if the value of top is -1, then it means the stack is empty in the beginning. So whenever we insert the first item into the stack, then that top is incremented by 1. So in terms of index, the top will contain 0, because in case of array the index starts from 0 to n-1, where n is the size of the array. So top will be incremented by 1. So let us see how we can implement using array concept. So I am not going to discuss the entire complete program. In fact, I will discuss only the function definition. So here we have declared a function with the name void push. So void push, its return type is void. It means it is not going to return any value, and there is no argument into the push function. So it means it is not receiving any argument. So the first step is if top is less than equal to size. Size is in fact the stack size, which is declared in the form of array, and that name of array is stack. So in the beginning, say we have declared stack 10. So it means the size of the stack is 10. So till initially the top will be initialized as -1 when there is not a single element inserted into the stack. So first of all we will check the overflow condition. So as I told in previous slide that during the push operation, first condition is to check the overflow condition. So overflow condition, if the top is less than equal to size, it means already stack is full. So in that case we cannot insert any new element into the stack. So what we can do, we can just print a message, say print a message that stack is full. Otherwise, if top is less than the size of the stack, then what we will do, we will take one element as input through scanf, say scanf %d and element. So here we read one element, an item of type integer. %d means it is element, the item which we are going to insert into the stack is an integer value. So we have taken this as an input and stored it into a variable, say integer type variable element, and thereafter we stored that element to the top of the stack, and we incremented the variable top by top ++. So this will be incremented, so that when again you call this function to insert another element, so the top variable will be pointing to the top of the stack. So this way we can implement the stack using array concept. So here in this case we can see that though I have not shown the main function here, but we can see that the top variable is declared, say, as a global variable. The size is also declared as a global variable, and this stack array is also declared as global variables. Then only this function will be able to access them. Otherwise, if it is local to main function, then it will not be able to access. In that case, we will be required to declare these variables as local inside this particular function. So I hope you understand how to implement the stack using array concept. Let me discuss the pop operation. So how we can perform the pop operation into the already created stack. So as I told that to perform the pop operation, first of all we will check the underflow condition. So underflow condition will be the case when top is less than equal to 0. So if top value is less than 0, that is -1, in that case it is empty. So in that case we will just print a message that stack is empty or underflow condition is there. Whatsoever message we want to print, we can print and then come out of the function. Otherwise what we will do, if top is greater than 0, it means at least there is one element into the stack. So what we will do, we will decrement the top minus minus. So in this case the top element will be stored in a variable, say element, and that will be printed, and top will be pointing to the second element, or the top element is retrieved and it will point to the second element of the stack from the top. So this is how we can write a program or write a definition of function of push and pop for stack if we are going to implement it through array concept. Similarly, as I told that it can be implemented using linked list also. The basic problem with array implementation is that we need to declare the size of the array in the beginning. So if we are not confirmed that how many elements there may be into the stack, then the array or the stack may be underutilized or it may be overutilized. For example, if we have declared, say, stack of size 100, but we are storing only 10 elements into it, so obviously 90 spaces are going to be underutilized, not utilized. Or sometimes we have declared, say, stack of size 10 and we are going to store, insert or push more than 10 elements into the stack. In that case it will not fulfill our requirement. So to overcome this problem, one can use in fact the linked list based implementation. In linked list based, because it is a dynamic memory concept based implementation, so we assign the memory dynamically at the runtime. So here is the function definition of the push operation. So we can see that it is this push operation is accepting two arguments. One is node start top, that is a pointer, and here node is in fact node is a structure variable. We can say that it consists of different fields. So those who know about the structure, you might be aware that when we declare the structure, so it consists of multiple fields. So here in this simple example, for example, the structure of the node is such that it is containing two components. One is the integer field, that is for storing the element, and one is the pointer field which is going to point to the next node, and that is node start top. So another parameter is int item, the item which is going to be pushed into the stack. So we have taken two parameters, one the containing the address of the top node of the stack, and another is the item to be inserted. So what we do in case of this linked list implementation, first of all we create a new node using malloc function. Malloc, we know that it is a dynamic memory allocation function. So we write temp is equal to node star malloc size of node. So by this it will create a node, it will assign storage to the node, and the address of that node is there inside the temp. And if as I told you that during the push operation, first of all we have to check the overflow condition. But in case of linked list, what will be the overflow condition? Overflow condition, we can say that it will be the case when the memory is not successfully assigned. So in that case we say that it is overflow condition. So that is being checked by if temp is equal to null, that is null is not going to contain any valid address, it is rather than it is containing the null. So in that case the memory is not successfully created and assigned to this variable temp. So in that case it will return, the function will return, come out of the scope. Otherwise if the node is successfully created, that is the shown by here by the else part. So what it will do, the item which is going to be inserted is going to be stored into the data part of the memory created, and that is being done by temp arrow operator data is equal to item, and then the temp next will be connected to the top, because if it is already containing the stack, then the top of the element or the last node of the linked list should be connected with the newly node. So the connection is going to be made through this, that the pointer field of the new node created should contain the address of the last element or top element of the stack. And then once connection is properly made, then top will be changed to top is equal to temp, that is it is going to contain the address of the last element which is been created. That is how the push function will work. Similarly, how we can write the program for pop function, let us see that. In the pop function, in fact, if we see the definition of the pop, so here it is returning an integer, its return type is integer. It means that we are going to return the item which is popped from the stack. So that value is going to be returned, and that because that is an integer type item, so here int pop is been written. So its return type is int, and thereafter the one argument is there, node star top. So what it means? It means we are passing the address of the stack, or we can say the top element's address of the stack is being passed into the function. And what we do next? We create another variable, say node star temp, and this temp is assigned the address of the top of the stack. Then we create another local variable, say item, which will be used to store the item which is going to be popped. So first of all, what we will check? We will check the underflow condition. Because it is a pop operation, so first we should check the underflow condition. So how we can check the underflow condition? If top is equal to null, it means there is no node existing. So in that case, it's underflow condition and it will return null value. Otherwise, what we will do? We will increment the top by top next, and item will be retrieved, which is going to be stored into the item variable, and that is temp data will be assigned to the item, and then that particular node is going to be made free, or memory is going to be released, which is going pointed by the temp, and the item which is being popped is returned back, because in the function definition its return type is int, so that item will be returned back to the calling function. The function which has called this particular function, it will be returned back to that function, and there we may display. So this is how we can implement the basic stack using linked list method. So let us see what are various applications of stack. Though there are a large number of applications of stack, but it is not possible to cover all the applications, so I have listed down few of the applications here. For example, to evaluate any arithmetic expression, what we do? We need the stack data structure. Any arithmetic expression, for example, a plus b plus c divided by d or something like this. So we want to evaluate this particular expression, then there is a use of stack. Or in data structure, those who are aware about the Polish notations, that is prefix, postfix and infix form. So conversion from prefix to postfix, prefix to infix, infix to postfix, postfix to infix, or prefix to infix, all these conversions are being taken place with the help of stack. And another widely used, it is widely used inside computer when recursive functions are called. Wherever there is a recursive function, we know that the function may be declared either in the form of recursive or in the form of iterative. So in the case of recursive function, by default stack is implemented. So those who are aware about the recursion, they might be knowing that there is a base condition. So base condition means when the recursive calling is going to stop. So till the base condition is not met, it is going to store the function into the stack, and it will retrieve one by one thereafter. In backtracking problems, this is being used. String reverser applications, this is used. And to implement the undo redo operation in text editor, that is where we can use the stack. So let us come to the queue. A queue is defined as another linear data structure that is open at both ends. Basically, in the case of stack, we have seen that all insertion and both insertion and deletion are performed at the same end. But here, in case of queue, the insertion takes place from one end, that is known as rear end, and deletion takes place from another end, that is known as front end or head end. So the basic operations which are being performed in the queue are basically in queue and dequeue. In queue means to insert an element to the end of the queue or to the rear part of the queue, and dequeue means removal of an element from the queue. And as I told that removal takes place from the front end. So here is the graphical view of the queue. We can see that there is a front end and there is a rear end. So insertion takes place from the rear end and deletion takes place from the front end. So this is about basic definition of the queue. And next thing about the queue we will discuss into the next lecture, that is how we can implement the queue, how we through either array based implementation or linked list based implementation. And also we will discuss the multiple types of queue like D queue, priority queue, in queue, input restricted queue, output restricted queue, and also we will discuss the applications of queue into the next session. I hope whatever we discussed here, you all the learners have enjoyed it. And if you have any doubt, you can write to me at my mail ID divakaryadav@ignou.ac.in. And that's all for today. We will continue this into the next counseling session. Thank you.